this is Kasturi Day, and today again I'll discuss the question answer series of the water chapter according to ICSE syllabus class 8. Okay, so I was continuing in my last video about the study questions, so I'll continue with that only. And then, how do the solubility of a solid and a gas gets affected by increase in temperature and increase in pressure? Okay, with the increase in temperature, solubility of a solid increases, and with the increase in temperature, the solubility of a gas decreases. Okay, so with the increase in temperature, the solubility of a solid can dissolve more of a solid, but we cannot dissolve more of gas if we raise the temperature. Okay, then with the increase in pressure, there is no effect on solubility of a gas. Okay, so pressure does not affect the solubility of a gas, but in case of solubility of a solid. Okay, but in case of a gas, sorry, the first is with the increase in pressure, there is no effect on the solubility of a solid, but increase in pressure affects, or rather increases, the solubility of a gas. Okay, with the increase in pressure, the solubility of a gas increases, but on the solid there is no effect with the increase in pressure. Next is differentiate between solution and suspension and colloid. So first we come to solution and suspension. So solution is a homogeneous mixture, suspension is a heterogeneous mixture. Then solution particles size is less than 10 to the power minus 10 meters, whereas suspension particle size greater than 10 to the power minus 7 meters. Solution is a transparent substance, but suspension is an opaque substance. Okay, the particles of the solute are invisible in a solution. The particles of a suspension are visible in a the particles of a solute are invisible in a solution, whereas in suspension they are visible. The particles of the solute are visible. Then the particles of a solute do not settle down in case of a solution, but in suspension they settle down. Okay, at the bottom of the container. Then in case of solution, the solute particles cannot be filtered because they dissolve. This is a homogeneous mixture. We cannot separate the solute from the solution by process of filtration. The solution passes easily through a filter paper, but in case of suspension, the particles of the solute are large enough, and so they can pass through they cannot pass through the filter paper, and so by this process we can, that is by filtration, we can separate the solute particles, the suspension particles, from the solvent. Then this suspension and colloid. Okay, the difference between suspension and colloid. Now the particle size is greater than 10 to the power minus 7 microns, whereas colloids are particle size between 10 to the power minus 10 to 10 to the power minus 7 microns. Okay, the suspension, they are opaque in nature, whereas colloid is translucent. Okay, colloid particles are translucent. Then suspension particles are visible to the unaided eye. Okay, without any aid we can see the suspension particles, but in a case of colloid they are visible only through a help of a powerful microscope. Okay, then suspension particles, they settle down at the bottom of the container, but in case of colloid they do not settle down. Whereas suspension particles can easily be filtered out, they cannot be easily be filtered out in case of colloid, but they can be separated by a process called centrifugation. Okay, then what is define water of crystallization, and give two examples with the formula. First, it is a fixed amount of water which is in a loose chemical combination with one molecule of a substance in its crystal form. So water of crystallization is that water, fixed amount of water which is bound together, or which is in combination with a substance, with one molecule of a substance in a loose combination. Loosely it is combined. Okay, so and that forms a crystal. So that is known as water of crystal. For example, hydrated copper sulfate, that is you can say blue vitriol or copper sulfate pentahydrate. So CuSO4 dot 5H2O is the formula. Then hydrated ferrous sulfate, or you can say green vitriol, that is other chemical name is iron 2 sulfate heptahydrate. Okay, so the formula is FeSO4 dot 7H2O. Okay. Next is, give two examples of each of the following, that is hydrated substance, that is washing soda and glauber salt. Then for crystalline anhydrous substance is common salt and potassium nitrate. Drying agents, concentrated sulfuric acid, phosphorus pentoxide, P2O5. Then deliquescent substances example is caustic soda, that is sodium hydroxide. Then crystalline magnesium chloride, MgCl2. Then efflorescent substance are washing soda, that is Na2CO3 10H2O, glauber salt, that is Na2SO4 10H2O. Okay. Colloids, milk and blood, solvents other than water, acetone and ethanol. Okay. Then we come to the next question. What do you observe when blue vitriol is heated? So blue vitriol is nothing but it's copper sulfate, that is hydrated copper sulfate. So it has water molecules, 5 water molecules. So when we heat that blue vitriol, it loses its water of crystallization and it becomes anhydrous amorphous powder. Okay. So what happens? This water of crystallization makes the copper sulfate as blue in color, and it will lose its color when heated to form grayish white. Okay, and that will be anhydrous form, powdered form. Okay. Then washing soda, in when it is exposed to air, what will happen? It is what this is a crystalline form, this white in color, and it's a crystalline form of sodium carbonate which has 10 water molecules. Decahydrate it is. Okay, so it has 10 water molecules. When it is exposed to air, it loses its water of crystallization and it becomes a white powder. Okay. Then pure water, it is neutral to litmus. Okay, pure water, when blue litmus solution is added to pure water, what happens? So it's pure water is neutral to litmus, and so it does not change the color of the any litmus solution. So neither it's blue or red litmus changes its color. So if we add blue litmus, it remains the same, it's neutral to it. So next is, give a balanced equations for the reactions of water with sodium, iron, carbon dioxide and sodium oxide. So first we come to sodium. Sodium reacts with cold water. Okay, the reaction is fast and it produces sodium hydroxide and hydrogen is liberated. Okay, so Na plus 2H2O gives us what? 2NaOH plus H2. Then hot iron. Okay, so when water reacts with iron, so iron has to be hot and the water has to be in a steam form. So hot iron will react with steam to form tri-iron tetroxide, and what will be hydrogen will be liberated. So that's a reversal. Okay, if you reverse the conditions, then it will come back to its reactant form, that is hot iron and steam. So the reaction will be like this, the balanced equation will be like this, that 3Fe plus 4H2O will give us Fe3O4 tri-iron tetroxide, Fe3O4 and 4H2. Then carbon dioxide reacts with water to form carbonic acid. So CO2 plus H2O will give us H2CO3. It's a balanced equation. Then sodium oxide plus water will give us sodium hydroxide, Na2O, sodium oxide, Na2O will react with H2O and that will give us 2NaOH. Okay. Then what is the metal activity series? It is a series of arrangement of metals in decreasing order of their reactivity. Okay, it's a series of metals, the arrangement of the metals, and like that it will be written in a series. Okay, from the above to the from top to bottom, the reactivity series will decrease in the order. Okay, from top to bottom. Okay, next is, name the gas which produces which is produced when steam is passed over hot coke. When steam is passed over hot coke, water gas is produced, that is carbon monoxide and hydrogen combination. Okay. Then chlorine is dissolved in water and exposed to sunlight. When chlorine is dissolved in water and exposed to sunlight, it will form hydrogen chloride gas. Okay, a piece of calcium is added to water, then hydrogen gas is produced. When fossil fuel is burned, carbon dioxide gas is produced. Next is define the following: soft water and hard water. Soft water is a water, it's an example of groundwater, which can freely lather with soap solution. Okay, we can see, no, when we wash our hands with soap, then if we see a rather frothy form of soap which is coming out very easily, then that is soft water. And if it is not forming, rather it's forming a sticky scum precipitate of soap, then it is a hard water. So hard water is a sample of groundwater that does not freely lather with soap solution but forms a sticky scum with soap. Rather, it's a form of precipitate with soap, it forms. Okay. Next is name the compound responsible for temporary hardness. Temporary hardness is caused by calcium bicarbonate, that is CaHCO3 whole twice, or you can say magnesium carbonate, that is MgHCO3 whole twice. Okay. Then compounds, then permanent hardness is caused by calcium chloride or magnesium chloride, calcium sulfate or magnesium sulfate. Okay. So I'll stop here. I'll continue with my rest of the question answers in my next video. Okay, and please go through this. If you have any doubt, do write in the comment box, and do press the like button, share with your friends, and do subscribe to get the notification of my next video. Thank you for watching, and have a good day.